Welcome back. Last lecture we are discussing about the Heisenberg uncertainty principle. So, we will give in this lecture we are going to give an alternate proof for Heisenberg uncertainty principle. So, there are two main operators in physics. What we do is that f with the state function, if you are acting, this is f of x, these two are the fundamental operator which is equal to f prime of x. One thing easy to notice is that if we look at the inner product of p f of g, this is equal to integral minus infinity to infinity x f of x, then g x bar dx, which is minus infinity to infinity f of x, and x is a real number. So, we can write this as dx, which is equal to minus infinity to infinity f of x p g x bar dx, which is f p g. Therefore, P is self adjoint. And in case of the Q, if we look at Q f of G, this is equal to minus infinity to infinity f prime of x, then this is G x bar dx. Now, if f is in the Schwarz space, so now by doing the integration by parts, what we get is that this is first quantity f of x, g of x minus infinity to infinity, it is going to be 0. So, by integration by parts, we get this is f of x, and then g prime of x bar dx, which is nothing but minus of f of q g. So, therefore, q star is equal to minus of q. Now, what we would like to derive the Heisenberg uncertainty principle using these two fundamental operators. So, now towards that end, let us define the Hermite operator, which essentially is I will define L f of x, this is equal to minus f double prime of x plus x square f of x, applying p and q twice, what we are going to get q star, and p twice, we will get this operator, that is the Hermite operator. Okay, so now what we will show that first the Heisenberg uncertainty principle will imply that L f f, this is greater or equal to f f for all f in the Schwarz space. So, now let us write, in order to apply the Heisenberg uncertainty principle, let us assume integral minus infinity to infinity mod f x square dx, this is equal to 1, then only we are going to apply Heisenberg uncertainty principle. So, now let us look at left hand side, which is L f f. So, this by definition is minus infinity to infinity minus f double prime of x plus x square f of x, this is L f, and then by inner product definition the f x bar dx. So, this is minus infinity to infinity minus f double prime of x, f bar of x plus minus infinity to infinity x square mod of f of x square dx. Okay. So, now if we do perform the integration by parts, then the first one f prime of x into f of x minus infinity to infinity is going to vanish. Then so what, then minus minus will be plus. So, this will be minus infinity to infinity f prime of x, and then this is derivative of that is f prime of x bar dx plus this is, so this is mod of, we can, so this is nothing but minus infinity to infinity mod of f prime of x square dx plus minus infinity to infinity x square mod of f of x square dx. Okay. So, then by using the Plan-Searle theorem, what we will get, that this is 4 pi square integral minus infinity to infinity xi square plus into mod of f at xi square dxi, the first one, and then plus minus infinity to infinity x square mod of f of x square dx. Now, this is a square plus b square, then this is going to be greater or equal to 2ab. So, therefore, this is going to be greater or equal to 2 times, this is 2 pi minus infinity to infinity xi square mod of f hat of xi square dxi whole to the power 1/2 into integral minus infinity to infinity x square mod of f of x square dx whole to the power 1/2. Now, we are assuming that the Heisenberg uncertainty principle is true, therefore, this is greater or equal to 4 pi into 1 over 4 pi. So, which is equal to 1, which is nothing but f f, because we are assuming that the integral mod f square dx is going to be equal to 1. Okay, now, if G is a Schwarz-Class, f is any arbitrary Schwarz-Class function, not the integral is 1, then the standard trick define let define G is equal to f by norm. So, what do I mean by that? This is equal to minus infinity to infinity mod of f of x square dx whole to the power 1 over 2. So, therefore, as you can see that integral minus infinity to infinity mod of g of x square dx, which is equal to 1. Therefore, we can apply, we know that L G G inner product, this is greater or equal to G and G. This will imply that L f by norm f and f by norm f inner product is greater than f by this. L is a linear operator. So, you can pull it out. So, this is L f f So, this shows that if Heisenberg uncertainty principle hold, then this is going to be true. Now, how to prove the question is that how to prove the Heisenberg uncertainty principle using these two fundamental operators. Okay, so as usual we have defined, let us say A is equal to A f of x, this is equal to f prime of x, that is q of f, and x f x, the p of f. Then as we have noticed, A star, this is going to be equal to minus of f prime of x plus x f x. Therefore, and now you look at A star of f. This is going to be A, or rather A star of A, if I want to look at A star, then acting on A f, this is equal to A star, acting on A f is f prime plus x f. Now, A star is equal to minus of f prime is f double prime. So, rather let us write one more step, minus of f prime plus x f prime plus x f prime plus x f. So, this is equal to minus of f double prime, and then the x prime is plus f plus x f prime, this is the first one, plus x f prime plus x square of f. Now, this is equal to minus of f double prime and plus x square of f, x f prime minus, and this is plus, will go away, minus of f. This is nothing but L minus of I acting on f. This is what is our A star A f. So, thus if we are assuming that so now you can see that A star of A f and g, this is equal to integral over A star A f at x g of x bar dx minus infinity to infinity, which is equal to I will first write down the definition of A star, then this is going to be minus of A f prime of x plus x time A f of x whole into g of x bar dx. So, if we do integration by parts, you look at that minus of A f prime is minus of A f into g bar of x, which vanishes. Then what we will get is that minus of infinity to infinity A f of x and then g prime of x bar dx. And for the next one, what we have got is that this is integral minus infinity to infinity A f of x, then x g x bar dx. So, this is minus infinity to infinity A f of x into g prime of x plus x g of x, this whole bar of dx, which is equal to a f, and then this is a g. That is what we have claimed. This is the linear algebra 1, what we are proving it. So, therefore, thus a star f a f of f, this is equal to a f a f, which is greater or equal to 0. Okay. So, now you define so as a consequence what we have got is that L minus I f inner product of f, that is greater or equal to 0. So, now what we want to prove the Heisenberg uncertainty principle. So, for that define a t for any t positive, you define a t f of x, f prime of x, any t real number. So, plus t x f of x, and therefore, just as before, one can say that this is a t star form would be minus of f prime of x plus t x f of x. Now, what we know is that a t star of a t of f comma f, this is greater or equal to 0, because this is nothing but the norm of a t of f, and a t star of a t of f, this at x, this if we do simple calculation, then what we will get, that this is equal to minus of a t of f prime at x plus t x a t of x. So, we will just take the derivative. So, what is a t of f prime at x? This is equal to f prime plus t x f whole prime, this is equal to f double prime plus t f derivative with respect to f, and plus t x f prime, and then if we are adding this two. So, this is minus, therefore, a t star a t f at x, this is equal to minus of f prime plus t f of x plus t x f prime of x plus t x into f prime of x plus a t is again t x f of x. So, this is equal to minus of f double prime of x plus t f of x plus t x f prime of x plus t x f prime of x plus t square x square f of x. Now, here there are the minus signs over here. This is minus, this is minus, minus, minus. So, then this is minus of f double prime of x minus t f of x, this gets cancelled, and plus t square x square f of x. Now, this is a quadratic equation on t. So, now if I look at a t star a t f o inner product of f, this we know that this is greater or equal to 0. So, this is t square and then x square f inner product from this, and then minus t f inner product, and then minus f double prime and f. This is greater or equal to 0. Now, this is a quadratic equation and on t which is greater or equal to 0. Therefore, what we have got is that 1 minus 4 A is f, c is f double prime of f. This is greater or equal to 0. So, this will imply that x square f inner product of f multiplied by f double prime of f, this is greater or equal to 1 by 4. And again, so this will imply that integral minus infinity to infinity x square mod of f of x square dx, and then what we have got is multiplied by minus infinity to infinity mod of f f, this is f double prime of x and f of x dx is greater or equal to 1 by 4. Now, this implies that minus infinity to infinity x square f of x square dx. Now, if we do again integration by parts, the what we are going to get is that this is minus infinity to infinity f prime of x square dx. This is greater or equal to 1 by 4. And then this will imply that minus infinity to infinity x square mod f x square dx, and this is nothing but minus infinity to infinity 4 j square. If I take it out, then this is by Planck's rule, which would be greater 1 by 4 pi square is coming out 4 pi square, that is. So, Heisenberg uncertainty principle, we can get it down. Thank you.